In this video, I'm going to go over question 3 from the November 2016 paper 2 for IB Math SL. It is a circle with center O and radius R. The circle is divided into 5 equal sectors. So we can figure out theta without too much trig because it's a circle. Circles are 360 degrees, or 2 pi if we're talking radians, and I'm splitting it into 5 equal sectors. So if you think about this little inner circle here, that has to be 2 pi completely, then each one of these must be the same. There's 5 of them. All I need to do is take 2 pi and divide it by 5, and that'll be theta. So the very first thing it asks us to do, write down the exact value of theta in radians. It's a 1-point question. The command is write down. It's supposed to be that common sense. Circle is 2 pi, divide it by 5, that's theta. The longer way to do it is to think about 360 divided by 5, get a 72-degree angle, and then attempt to convert that to radians by multiplying by pi over 180. It works, it's just a very long process for a very simple concept. Then we're told the area of sector AOB is 20 pi, and asked to find the value of R. So we're given area of a sector. The formula that we would like to use is in the formula booklet for the area of a sector. And that formula is area equals 1/2 R squared theta, as long as theta is in radians. So you could not put a 72-degree angle in this formula and have it work, but you can put the 2 pi over 5 in for theta and solve for R. A common mistake is replacing A with 20 here, but A is 20 pi, not 20. R is the thing we don't know and are trying to solve for, so I will leave it as R. And theta is 2 pi over 5. And this can get a little bit hairy trying to solve it, but it's not that bad. In addition, it's a calculator test, so you could even use the calculator to help you. But I'm going to attempt to solve this one analytically. It's not that difficult. I'm going to multiply by 2 first to get rid of the 1/2. And I'm left with R squared and then this radian angle. You might then multiply by 5. You might multiply by the reciprocal of this fraction, 5 over 2 pi. So try to find the way that makes sense in your brain. By multiplying by the reciprocal, 5 over 2 pi on both sides, it's going to cancel out this entire angle all at the same time. And it's a little bit easy on this side to see now that the pi's cancel each other out, and that's going to make our lives a lot easier. 40 and 2 can also reduce to 20 and 1. So if you're attempting to do this without a calculator, now you have a much easier multiplication problem to do. It's just 5 times 20, which is 100. 100 equals R squared, and then you could plus or minus square root, but we don't need the negative square root because it's the radius of a circle and it can't be negative. And so 10 millimeters equals R. And then find AB, and this means the line segment AB. So if you're looking up at this picture, it's asking you to find this AB, not the arc AB. If they were asking to find the arc AB, they would have to say arc or show you this symbol here, which they have not done. So they mean the line segment AB. And if you scroll back up to that picture, now that we know this is 2 pi over 5, and we know that these are each 10, we can use the law of cosines in this triangle to find that length AB. So the law of cosines says that AB squared, the side we're trying to find, would equal 10 squared plus 10 squared minus 2 times 10 times 10. I'm just going to get rid of this work here since I ran out of space. Times the cosine of 2 pi over 5. A couple of complications to this is that you'd need to make sure your calculator was in radian mode if you're about to do the cosine of a radian angle. And another thing that I've seen, 100 plus 100 here is 200. And then 2 times 10 times 10 is also 200. So 200 minus 200 cosine of 2 pi over 5. You absolutely cannot subtract this 200 minus this 200 and get 0. This is attached by multiplication. You cannot subtract the 200 away from it. But at this point, you should just be going to your calculator anyway and then square rooting your result because this is AB squared. So in the end, you go to your calculator, you type this whole thing in, making sure your calculator's in radian mode, square root your answer, and AB ends up being 11.8. And that is it.